Imagine you're a detective and have a case that involves optimizing a report by using various tools and techniques to improve its performance. You need to investigate how the report elements, like visuals and queries, are performing and find out the best ways to fix any issues that might slow down the report. You also need to understand how the data model works under the hood and how you can use tools like DAX Studio and Tabular Editor to optimize it. Along the way, you'll learn some best practices and tips to make your reports more efficient and user-friendly. You ready to take the case? Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Grab your investigative gear and let's get started. Here they are, our prime suspects. Optimizing your report solutions can take place at the level shown here. Typically, the data is through direct query, or we're relying on the data source performance in our models, then the data source is the prime suspect. The typical culprit is the data model, as there is so much opportunity for optimization there. Even visualizations themselves can be a suspect, especially when several visuals are associated with interactions or you have too many visuals in a report page. Finally, our environment assets like capacity settings and data gateway clustering and sizing can be suspects as well. Detectives always have their list of prime suspects handy, and as a formidable detective, you should too. Optimization is where real investigation takes place, and for that, we need our investigative tools. Let's look at our toolkit for Power BI report optimization. We'll introduce these tools as we move along through the case, starting with Performance Analyzer, then DAX Studio, and rounding it up with the Best Practice Analyzer, or BPA, via Tabular Editor. The first tool in our investigative kit we're looking at is the Performance Analyzer, which is built into Power BI Desktop. The Performance Analyzer helps you understand how report elements like visuals and DAX queries are performing. The Performance Analyzer is a great place to start when you're optimizing reports. Performance Analyzer displays and records logs that measure how each of your report elements performs when users interact with them. You can also see which aspects of their performance are most or least resource intensive. You can immediately see results, make changes, run the analyzer again, and see the impact of the changes that you've made. To use a Performance Analyzer, enable the Performance Analyzer on the View tab of the ribbon and select Start Recording. After you start recording, take actions on the report. For example, move from one report tab to the next, select a slicer item, or interact with any of your visuals. Any actions you take in the report are displayed and logged in real time in the Performance Analyzer pane in the order that the visual is loaded. The Performance Analyzer is looking at the time it takes for each visual to query the data model and render the results. This is the time from when a user does something on the page to when the visual is rendered in milliseconds. In the example below, 3 actions were taken after recording started. First, we navigated to a new report page. Second, we changed the slicer value. And then third, we cross-highlighted a table. Each visual's log information includes the time spent or duration to complete the following categories of tasks. If a DAX query was required, this is the time between the visual sending the query and for analysis services to return the results. Evaluated parameters provides the time spent evaluating the field parameters within a visual. Currently, this is a preview feature. Visual display provides the time required for the visual to appear on the screen, including time required to retrieve any web images or geocoding. Other is the time required by the visual for preparing queries, waiting for other visuals to complete, or performing other background processing. After you've interacted with elements of your report you want to measure with the Performance Analyzer, you can select the Stop button. The performance information remains in the pane after you select Stop for you to analyze. You can select Refresh Visuals in the Performance Analyzer pane to refresh all visuals on the current page of the report, which will gather information about all the visuals. If one visual appears to be performing slow, you can also refresh individual visuals. When Performance Analyzer is recording, you can select Analyze this visual found in the top right corner of each visual to refresh that visual and capture its performance information. As users interact with visuals and reports, DAX queries are submitted to the semantic model and cached into memory. Because of this, you may need to clear the DAX query cache to get accurate results in the Performance Analyzer. You can clear the cache by either closing and reopening your report or using DAX Studio. For queries with longer duration times, it's likely that a measure is written poorly or an issue has occurred with the data model. The issue might be caused by the relationships, columns, or even metadata in your model, or it could be the status of the auto date time option. You can save Performance Analyzer results by selecting the Export button, which creates a JSON file, not this one, containing the results. Now that we have found some potential suspects using Performance Analyzer, we can take those clues and then have them analyzed in DAX Studio. You can import the exported performance data into DAX Studio, where you can view, sort, and filter it. You can also bring a single query into the editor, where you can adjust the query to improve performance. What is DAX Studio, you may ask? Oh, looks like I've said DAX too much and my best pal, DAX, thought I was calling him. Sorry, DAX, false alarm. You can go lay down. DAX Studio is an open source tool for executing DAX queries against semantic models and analysis service models. DAX Studio is useful for reviewing the contents of your data model and even writing and optimizing complex DAX formulas and queries. You can download and install DAX Studio, and it can be launched from the External Tools tab of the ribbon Power BI Desktop. Calculations using DAX, either measures or columns, are a part of a DAX query, which is processed by two engines in VertiPaq. The VertiPaq engine delivers fast access to tabular model objects and data by using compression algorithms and a multi-threaded query processor. When a query is processed, the formula engine processes the request, asks the storage engine for data, and performs necessary calculations. The storage engine retrieves and aggregates data requested by the formula engine. In this diagram, the DAX query is sent to the tabular model in steps 1 and 2. The request is then processed by the formula engine and sent to the storage engine, represented by step 3. In step 4, the storage engine either retrieves the data from the model and stores it in memory for import mode, or passes the query onto the data source for direct query mode. For import mode, refreshing the data will retrieve the data from the source. Troubleshooting in DAX Studio enables you to see detailed statistics on the server timings of your query. You're able to view the proportion of time the query takes in each engine and can then adjust your queries accordingly to improve performance. But that's just one way DAX Studio analyzes our performance clues. Viewing the VertiPaq Analyzer metrics in DAX Studio is a great way to get an overall view of what's going on in your data model. VertiPaq Analyzer reports the memory consumption of the data model and can be used to quickly identify where you're spending the most memory. In short, you can use VertiPaq Analyzer to make memory gobbling offenders obvious, rectify them, and then rerun VertiPaq Analyzer to see the immediate benefits of your data model updates. Viewing the VertiPaq Analyzer metrics will only be helpful for import or composite models, since direct query models send the query back to the source, not VertiPaq. You can look at the size of the table, columns, and etc. in bytes. The displayed sizes in bytes are evaluated prior to the compression. To view model metrics, launch DAX Studio from the External Tools tab of the ribbon and select View Metrics from the Advanced tab in DAX Studio. Viewing metrics in DAX Studio helps you immediately find and fix problems. For example, Notice that the model in the image contains a table that's consuming 99.6% of the database memory. By drilling into the table, you can see that two columns, end date and start date, are gobbling up most of the memory. You can then fix that issue, refresh the metrics, and immediately see the effects of the changes on the model. Now, how can you be sure to implement data modeling best practices as you design and build data models? There's a tool for that. The Best Practice Analyzer, or BPA, in Tabular Editor can be used during the development of tabular models, in semantic models, and even analysis services models. Tabular Editor is an alternative tool for authoring tabular models. Tabular Editor 2 is an open source project that can edit a BIM file without accessing any data in the model. Tabular Editor enables users to easily manipulate tabular models and can be used in a few different ways. Some examples can be to quickly edit data models. You can automate repetitive tasks using scripting. You can incorporate DevOps with tabular models. And what we'll talk about here, run BPA rules. BPA is a set of rules run in Tabular Editor that notify you of potential modeling missteps or changes that you can make to improve your model design and performance. It includes recommendations for naming, user experience, and common optimizations that you can apply to improve performance. To use the predefined BPA rules, download the BPA rules JSON file from a GitHub repository. The rules are divided in categories like performance, DAX expressions, error prevention, and formatting. Each rule has a description, and many of the rules also have a reference article and video. Reading the rule description and article will provide context as to why the rule is important and why you should follow it. BPA rules can be run against tabular models in Power BI Desktop, SQL Server Analysis Services, Azure Analysis Services, or Power BI Premium. BPA was designed to enable you to create custom rules and best practices for your organization. If the BPA rules don't suit your needs, you can create rules required for data modeling best practices as you deem appropriate. You can also edit existing rules, disable and ignore rules, and set severity levels for each rule. Edits you make to best practice rules in this window will then be saved to the JSON file. If your organization has an established continuous integration, continuous delivery process using Git, BPA can be integrated into your Azure pipelines. If objects violate best practice rules in the build, you can establish a process to either fail the build or proceed with warnings based on the severity of the violation. Enough talk. Time to put knowledge to practice. That's right, time to fire up the DetectoLab 5000 and get optimizing.
Welcome back to the environment, and we're going to talk about optimizing our models, whether this be through DAX manipulation or iterating through our visuals, utilizing tools like DAX Studio and then Tabular Editor to apply best practices to our model. So first, we're going to need a report in order for us to visualize this. I want to show this cool feature in our models is that I can actually take one of these models and I can auto create a report out of it. So let's do that. It'll let me pre-select the data out of here as well. So I'll just select all these in this model. And it's going to pre-generate a report for me. Now, it's probably not the most intuitive, but at least it's a good starting point, and it'll allow me to at least demonstrate what I'm going to do from the performance perspective. So now I can view this report, but more importantly, this gives me the opportunity to perform some performance analyzer on this. Let's see how the auto report did from a performance perspective. So what I'm going to do is I'm going to go ahead and save this and name this, I'll call it sample report 2 because I have sample report 1 in here. And now that I have this saved, I can actually download this file locally. Why do I want to do this? Well, I have to I have to run Performance Analyzer in Power BI Desktop. I can't run it through the browser. So I need to open this up. I think this is also another good thing to point out is that we enabled large semantic models earlier. And if you notice, I can't import the data when I have large semantic model selected. Why? Because the model could be 500 gigabytes and then it has to download that entire file into my local system. So it doesn't do that. It only let me utilize a live connection, which is similar to connecting to like analysis services or something like that. So when I connect into Power BI Desktop, then I should be able to open up the report. The difference being is that it's going to make a live connection. It isn't like direct query or import mode. It's like connecting to an analysis services cube, essentially. We're going to open up this report though. And since I just downloaded it, it should be here. Boom. And again, this is just for us to run our performance analyzer on this. So now I got it in Power BI Desktop, right? I got Power BI Desktop opened up. I'm connected, logged in, I'm authenticated, I'm all ready to go. So where do I start running visuals, performance analyzer on here? Go into the view ribbon, and then you can see performance analyzer is right there. What you might have to do again is you may have to clear the cache out. If somebody has already been interacting with the report and you want to start performance analyzer, what happens is when a report is open, it starts caching that information. Now there's a couple ways to kind of deal with that. I can go into my options and set without actually closing the report. If I go into my options and I look at the data load under our cache, you can see that I have cache like 6 kilobytes. And that's usually because of interactions. I can clear the cache that way. I can close the report, open it back up. That'll clear the cache as well. Once I have that cache cleared out, let me move the performance analyzer over a little bit. Then I can hit the start recording button, and any interaction that I make now with the visuals are going to show up in this performance analyzer report. So I could select certain items within here, and you can see that since all of these visuals have interaction built into them, I make a selection on one and it filters all of them. This can cause performance problems. As you can see, there's all these different things it has to do just to perform that one operation. I can also, if you see this, analyze this visual, I can just hit that and it'll analyze that particular visual itself, just a refresh on it. Same thing with all these individual ones. I could monitor each one and see which ones have the longest times within them. And then I can make a couple other, selections on here and get all this and get these times in. And you can also see that it creates every effect that it has when I make that interaction. These multi-card rows, probably these visuals are going to be the most interesting to look at, is that it gives me things like the underlying DAX query, how long it took it to run, how long it took the visual display for it to re-render, and then some other background operations that it took. Sometimes those are a little out of our control, but it only shows me what happened within it. Like a text box doesn't have a DAX query running into it, so it's not going to show that aspect of it. But there'll be different details for different ones, for different interactions that we make with this. And we can analyze each individual visual itself, right? So we just refreshed the visual and it ran DAX queries and everything else on there. So now we can hit stop. We've done some analysis on this. And at this point, I can export this and it'll export it into a JSON file. I already have one here, but I'll go ahead and rewrite it. And then if I want to, maybe test out some alternative DAX functions, not you, DAX, you can go lay down. Not DAX functions, but try out different DAX functions that might work a little bit better than the one that we currently have implemented, or a different way of structuring it. Maybe break it up into variables and do it that way if we're finding a lot of things. There's ways to handle it, but we have to find out where we can do all this without really affecting the model itself and any of the visuals. It takes a long time to enter measures and have the visuals have it applied to the visuals. So I need a tool that allow me to do that, and that's what DAX Studio is. So I can open up DAX Studio. Once I install it, it actually shows up under my external tools. And then it's going to connect. Since I have a live connection, remember our model here is on a live connection. So it's got to go into the Power BI service to connect to this model. Once it does, you can see that it's connected to this. And now I can look at all my tables associated with this. You can see that it's all connected. And then I can do things like find my server timings with it. But what I want to do is I want to load this performance data. So I have that and I have my performance data. So now I can open it up and you can see that everything that occurred in there, everything that every interaction that I made and every visual that was analyzed, all the underlying DAX functions are contained within here. So now I can just copy the query, paste it in here, see what the results are from a timing perspective, and then manipulate the DAX queries to get better performance out of them. I can also go into server timings and see what the performance is on certain queries that I run. So if I run a DAX query in here, let's go back into this performance data real quick and see if I can, or maybe even get into, do I have a measure? Oh, in my fact cell, I got a couple measures, right? I don't see any here. Okay. Well, anyway, you can also run the server timings on that. I keep this demo a little bit shorter. A lot of content covered in that. But I can also get into here and run server timing. So if I have a DAX query that I want to write, I wish it would let me do this. I can run server timings on it. I don't think this is going to run very well, but you can see here is that it has my storage engine and the storage engine and the function engine that performs the DAX timings on this. And then I'll record it. I can stop it and get the results from that particular query to see where the performance throttling or issue is taking place. Is it happening in the formula engine or is it happening in the storage engine? I think I said function engine earlier. It's formula engine. So is it happening within the DAX formula itself, or is it from grabbing the data from the server? This is where server timings can help us get a better sense of where the actual problem in the query is happening to improve the performance of our visuals. All right, I won't save this, but what I am going to do is finally I'm going to open up Tabular Editor. And again, this should connect to the model once I have this. So now I have this live connection again. This will open up our model. And best practices analyzer is kind of what I wanted to show on this. Just under the tools, we have our best practice analyzer. And what I can actually do is add the file in here. I can manage rules. I can add, include rules from a local file. And then it'll open up my browser. And I think in my desktop, I have the BPA analyzer here. Yep, BPA rules. And it's a JSON object. So what happens is now it's applied all these rules in here. So these are best practice rules from this JSON file. Now I don't have to keep all these. I can keep all these rules. And what'll happen is that it will do certain things based on the rule that's applied to here. And a lot of this has to do with referential integrity and some other things contained within here that are going to help make our models run the best out of the box when we apply these rules to them. But I can go in here and I can change rules, like I can select rules, I can change them if I wanted to. But it's always good to have that best practice analyzer in there, because now that I got the rules in here, I can take the effective rules and then I can select certain ones that I do or don't want to to apply into this and edit those out. And then once I save this, it should save it to the model and when I publish it back to the service, it'll include all those best practice analyzer rules in here. So the next time somebody opens up the report, it'll be managed by those best practices that we implemented. And that JSON file is located in GitHub. All right, so I think we did a good job of just covering some of the basics of optimization, looked at Performance Analyzer to perform analysis on our visuals. Take that information, move it into DAX Studio. From there, we can test our queries out, try to improve them from there. We can also perform server timings on the queries, see what's happening from the formula engine and the storage engine, where the root cause of the problem is with that particular query is happening. And then being proactive and applying best practices before we even get started with our reports, applying these best practices to our models in order to have our models work really good out of the box. All right, back to the studio.
Great work, detectives. We covered optimizing reports by using various tools and techniques. You learned how to use the Performance Analyzer, DAX Studio, and Tabular Editor to investigate and improve the performance of your data model, DAX queries, and visuals. You've also learned how to use the Best Practice Analyzer to check your data model against a set of rules and best practices, and how to customize and integrate BPA into your continuous integration, continuous delivery process. Thanks for joining.